All right. Hela svenska jävarna där. Ja. I Finland kodar vi fortfarande i assembler. So I'm just telling our Swedish crowd that over in Finland, we're still programming in assembler when you guys over here in Sweden are doing Java. How cool is that? We're old school. We like SIM cards and embedded technology and embedded C. And IoT is a little bit like that. It's about two worlds coming together. The world of assembler on small devices, handcrafted stuff, and the cloud and the web and people and mobile apps. And it's actually you guys that we need to make all this IoT stuff come together. So we'll talk about, first, what is IoT? So I saw a lot of people are kind of new to this space, and that's cool. We'll talk about the really basics, back to history, where did the internet come from, and then from that we'll understand actually what IoT is all about. And I'll go right into some of the technologies, some of the standards, what's happening, what's the coolest trends, and then what the future really is. So don't let my title confuse you. It says marketing, but I'm really a technical guy. So I have a long history at the IETF doing standards for the internet in general, IPv6, and IoT specifically. I'm also on the JCP exec committee for ARM. So if you want to talk about Java too, we can do that. So let's go back in history a little bit. In the 1980s, we had the first beginnings of what you could call the Internet of People. Forget about the internet before the 80s. That was for real nerds, right? Those are gray-bearded guys at the IETF these days who hand-coded all of their IPv4 stuff, all academic. 80s, we got something that changed the world. The modem, right? Anybody have one of these? I'm old school. 1200 baud. It was like, woo, speed, right? This created the first Internet of People, the modem. We talked to each other through, what? Anybody tell me? Bulletin board systems, BBS, man. Forget about the internet, we called direct. We skipped everybody, right? I'll tell you why that's important for IoT in a moment. Bulletin board systems, and that was, yes, nerdy, very nerdy. I had 5 phone lines coming into my mother's house as a kid. So people could call me on their computers. It was really cool. Actually, it was worse. The 80s was worse than this. The 80s actually looked like that. Much worse. That wasn't me. Now, if the internet would have continued on this round of BBS, it was ANSI color UIs, it would look like this today. So Google actually did a Telnet-based BBS interface to Google search with ANSI text, right? ANSI art. This is very cool. So this is the Internet of People. It started out with modems, started out with people just using communications for each other. Eventually it moved to TCP/IP and you telnetted to bulletin board systems. That was still in the 90s. Then it got really cool. We had the Internet of siloed people. Now, over here in Sweden, you probably didn't really have American Online, but in the US, this was the big thing. We had the internet so that we could use an AOL browser to talk to the AOL content. That's all you could do, right? So this was the internet of very siloed things. There was no content on a web page. You could just go with your browser to somebody's web server. There was none of that. The web was a very boring place in the early 90s. And then a big change came. We got web technology, right? Internet was kind of useful before that, but we got the web. We had browsers that could talk independently to web servers, and we had a markup language, HTML, that anybody could create content, anybody could deploy an application. And now we end up what we have now, which is tons and tons of different applications nobody could ever have dreamed up at that time. And that's the key. In the early 2000s, late 90s, the web became an innovation platform. That's all it was. It wasn't us tech companies that came up with this stuff. We had no clue. We thought it was going to be like business systems that made the internet what it was going to be and make all the money. It had none of that. Right? It was social media, it was streaming video, it was everything else. So people created all this. All the content was created by inventors and people that had real problems to solve. So the web is a platform for innovation. All right, so let's go back to the Internet of Things. So I've been doing automation for a long time. Automation for devices, for things, looked like this. This is a big PLC rack. From the 60s to the 90s, it didn't change, right? All wired up, all specialized control circuits. The 90s got us things like Profibus and Modbus, which were no better. Very specialized modems that talk to each other over a line, point to point. Sounds a lot like modems for bulletin board systems, right? So the Internet of Things in the 90s was still bulletin board systems. Now, the Internet of Things in the 2000s, when I was first getting started working in this field and really trying to change how things were working and saying, hey guys, why don't we use the Internet, 2001? Everyone was like, oh, why would we want to do that? We've got this great stuff. Look, we can connect with my specific proprietary thing. I can connect my device to my service, and look how awesome and optimized it was, right? So this was the Internet of content silo things. It was always my thing in my service, and they couldn't talk with anybody else. This took years to develop one of these systems, so it was a lot of work, a lot of engineering, a lot of fun. Now, what's really happening now? What's this IoT hype all about? I'll tell you what it's about. It's about this. This is the paradigm shift. It's really simple. Now we're connecting things through the internet using common web technologies, common security. Now we've got devices that act like web browsers. They can talk to services that act like web servers, and people can invent whatever they want to do on top of that. Whether it's home automation, whether it's smart city applications, whether it's something that will completely change the world. Now people can do that. And that's what the IoT hype's all about. It's really simple. This is just the next phase of the web innovation platform coming to things rather than just to people. So keep that in mind. Just cut through all the hype. This is now a platform for technologists, right? So all you guys can create cool stuff. And it's very much about cloud guys and embedded guys now talking to each other than just about one or the other, right? So I think this is the right place to be talking about IoT, actually at JFocus. Now, this is one little factoid that I found really interesting, and that's that by 2018, more than 50% of the solutions, that's where all the money is, forget about technology, solutions, right, will be from startups that are less than 3 years old. That means they're getting started right now, right? Completely new startups. And that's huge, right? That hasn't happened since the really early web days when stuff was kind of just coming out. We haven't seen anything like that in technology. So this thing space is very much a startup space. People doing Kickstarter projects, reinventing everyday things. So like Tony Fadell and Nest, that was the beauty of it, took a thermostat. Who would think you have to reinvent a thermostat, and reinvented it and made a thermostat sexy, right? Which is very cool. A lot of the innovation will be reinventing everyday things. Some of it will be reinventing or inventing completely new things. So this is why it's important that we are creating an innovation platform. ARM, Oracle, wherever that you work, we have to create the technology for people. So let's look at innovation in the early 2000s in this space. This is a slide from ARM's CTO, Mike Muller, great guy, looking at what was new and cool in technology in 2001. Can anybody guess what this is? Probably can't. This is a toaster that can actually print information on your bread. So it goes and fetches the weather. You haven't looked outside yet. It's Sweden, right? Your shades are down. It's cold outside. And you see on your toast, oh, it's going to be sunny today. That's Internet of Things. That was interesting. That was back in 2001. I'll talk more about toast a little bit later, to use a couple examples. All right, so I come from a company called ARM. I'll tell you a little bit about what we do, just so you understand why in the heck I even care about this stuff. So ARM is really the biggest chip technology company in the world, except we don't make chips. It's pretty cool. We design all the chip technology behind the ARM architecture, both in microcontrollers, so all down to really tiny sensors, all the way up to mobile, and now 64-bit servers. So now we're into cloud infrastructure. You just saw some of the first ARM-based 64-bit server chips announced by HP and others. So now we're getting into whole rack systems. And the cool thing about that is we can actually work with a big number of actual chip makers, from Texas Instruments to Atmel to MediaTek to Qualcomm. And make sure that they're using the same compatible architecture across lots of different chips. So that means there's no one-size-fits-all, right? They can make a special system on a chip for this one battery-powered sensor, and then they can make a quad-core A7 for the new Raspberry Pi. Broadcom chip in the new Raspberry Pi. Very cool, ARM-based. All the way up to really high performance. There's like a 48-core, 64-bit server workload chip from Cavium. That's really cool. So that whole range with the same instruction sets, really nice. And there were over 10 billion of those things shipped in 2013. We haven't put 2014 numbers. 10 billion in 1 year. What I think is cool about that is that actually over 4 billion of those were related to IoT, embedded applications. That's a real market, right? If we can get even a fraction of those billions of devices speaking standards, speaking the web, right, security, then you can do some very cool things. That's what gets us excited about IoT. We have a common architecture. So we think we can help people to create applications. Now, there's no one-size-fits-all in chips. So I talked a little bit about the different kinds of chips. I'm going to use a couple examples here while I talk. So this is just a tutorial, right? We have really small sensor-like things. This is we call it Cortex M0. So this goes down to like a Bluetooth Low Energy connected temperature sensor, for example. So we're talking about 16K of RAM, 64K of flash. That's the kind of device. No Java, right? This is C++, C. Up to what's in my Suunto sport watch, Cortex M3. That's 32 to 64K of RAM. Now we can do lots of cool internet stuff. We can do TLS-based security, all that, and still native. We're probably not going to run Java there. More recently, and I'm going to talk about Java in this space, more recently we have pretty powerful devices. We're talking about hundreds of K of RAM, usually about a meg to less than a meg of flash. We can actually run Java ME8, which is cool stuff on those. So this gets to the space where actual embedded and the Java world hit each other. All the way up to A-class, which is mobile, basically a mobile platform. That's what goes into gateways, Raspberry Pis, and you'll see something called Java SE Embedded become pretty popular on these. So there is Java in this space. Now, the reason why all this diversity is needed is actually when we look at the types of applications that are going into this space. So we just talked about there's big diversity, but you really see it when you look at the number of units compared to application. So the big ones in the space are kind of like mobile, set-top boxes, things like that. When you get into the IoT applications, there's this really long tail. There's no one application that has huge volume. So that means we need to have lots of diversity in software, but we have to have it all compatible and reusable technology. So without the technology, we're not going to be able to drive all these applications. Now, there's two key things that I think have to happen this year for IoT to really move forward, and I'm going to try to touch on both of these. One, in the embedded space in general, we've been missing a software ecosystem. So actually there has been no software ecosystem in embedded. It's been a really fragmented set of specialized tools. You need this tool chain for this chip. They've got their own software stack. Oh, you need TLS. Oh, you got to go buy that over here. It's under a different license. You got to integrate it. So you really need a team of really specialized embedded engineers to make any kind of product. And oftentimes you need a team of specialized cloud people to make any kind of service. So it's just not scalable, right? We need the toolkits that we have in mobile. You want to make an app. You get what you need to make the app. You start prototyping. There's a marketplace. You go put it to market and sell it, right? That's a whole ecosystem. So we need to create this for embedded. Otherwise, there's not going to be a real IoT. The other thing is standards. Okay, we have lots of standards. We've been doing this for already over 10 years in the IETF. We've got lots of cool stuff we can use for IoT. That's not a question anymore. But standards without having them available for developers is kind of stupid, right? So what's the point of having TLS without making it available to every single developer for free? So that's something we're trying to change is how do we get software to developers so that they have standards? These two are related to each other. So I'm going to talk a little bit about standards. I'm not going to talk about all of them, but when you look at IoT, actually the standard stack looks a lot like it does for mobile and web. We're based on internet standards. I'll point out a few differences. So there's some interesting things. We talk a lot about IPv6 in this space. So we actually are leveraging a lot of the new IPv6 technology to get IP in places it's never been. Remember all those PLC automation buses? Those are still really low bandwidth networks. They're getting a little bit better, but it's definitely not Ethernet or Wi-Fi class of communications. So we have things like Thread, a new standard I'll talk about in a second, or Bluetooth Low Energy, which we're doing IPv6 over with some of the new standards. With those, we can do things like home automation in a very efficient way and still make it part of the internet. So this is about getting stuff into IP. The rest of the stack looks pretty similar, right? You guys know TLS. We use TLS in this space. It's actually become our security of choice in the IoT space because we can leverage all the machinery that's out there and because we can adjust the cipher suites down to what we need. So we don't use exactly the same cipher suites we use in the big web. We have some new stuff in here, which is REST, but it's REST for efficient devices, something called CoAP, Constrained Application Protocol. I'll tell you about that. And of course, DTLS, Datagram TLS, because we need TLS still over UDP. It's really the only difference. And then we have the equivalent of HTML. We do markup for small devices. It's a little bit different. HTML expects that there's a human eyeball in the loop that can search for links and stuff on a screen. We do different kinds of object models that we use for device management and we use for actual data. And those are a little bit more specific. There's an actual object model that tells you what the temperature is, and a machine can go and look at that and know exactly what the temperature is, or location or anything else. So these are what we call objects. They're part of the lightweight M2M standard from OMA, and the IPSO Alliance does object models for free. Post them on the web around that. So we have a whole community of open standards. These things are all freely available to people, so it's not a hard thing to go and use these and pick them up. So I'll tell about a couple of these that I think are really going to change the industry in the near future. One of these is Thread. So for a long time, these home automation networks have been a huge mess. In smart cities, we've started to already move towards IP-based networks a long time ago. Home automation's been a mess of Z-Wave, of Zigbee, of Bluetooth Low Energy without the internet. It's kind of nice, but it's only an app accessory for your phone. Otherwise, you can't really hook it into a cloud service very easily. So how do we go past that? And one thing that we did is we saw, well, there's a whole bunch of partners that are interested in doing this. Why don't we get together, make use of some of the new standards from the Internet Engineering Task Force, like 6LoWPAN, which are hard to use on their own, right? You have to really know what you're doing and set everything up. Why don't we make it something more like Wi-Fi? And that's what we did. So this new Thread standard is Wi-Fi for home automation. Think of it that way. A little bit different radio standard, but the idea is exactly the same. It gets you IPv6. You can communicate with the internet. And this is something you're going to see coming out this year, and we'll see even makers of gateways for the home putting this in their devices, and this is already actually deployed by Nest. So Nest uses this in thermostats, they use it in fire detectors, and all kinds of third-party devices that are now coming out. I love this company here, Big Ass Fans. That's my favorite. They make fans. I don't know if you've ever seen a magazine advertisement in the US, but they make Bluetooth Low Energy and Thread compatible big fans that you can control with other stuff. Now, let's talk about the web a little bit. So if we want to do web for devices, we need web-like communications. HTTP is nice, and it's not going to go away. We use a lot of HTTP. But it's not always appropriate for everything. So in the early 2000s, what everybody did was invented their own UDP protocol. We actually saw this happen. We went and gave them great technology, and they said, well, there's no protocols for UDP, so we're going to invent one. It's fun for engineers. We love inventing UDP-based protocols. You can do congestion control and everything. We said, okay, that's enough. We don't need to do that every time. So we went to standardization. We created a protocol from the IETF. This is RFC 7252, which basically gives us really compact REST requests and responses over UDP. Doesn't do congestion control, just does one-off acts. So it's n* equals 1. That means you send a packet, get a response, and you send the next packet. It's not high bandwidth. You're not going to stream a movie over this. You'll stream temperature, but you won't stream a movie. There's a very cool protocol based on DTLS for security, and you can go get a whole bunch more information at coap.technology. We actually put a web page out there with all the open source implementations, etc. And just recently, or last year, we made an announcement with Oracle that we're actually starting a new project around this in OpenJDK. We thought that, it kind of sucks that there's no CoAP native implementation in Java out of the box. Why don't we fix that? Well, it turns out that ARM's actually been working on implementations of this for many years, and the very first implementation of CoAP ever was written in Java. And the actual developer is here, Schumann, up there. So the actual Java developer of this protocol, the very first one, was done in Java. And it's gotten a lot better, and we're actually now contributing it to OpenJDK. So I hope next week things open up for Project Kona. OpenJDK, we're actually going to contribute the code, be available open source, anybody can use it. Obviously, it'll take a little time to get into Java, probably into 9, maybe late 8 if we're really lucky. So very cool. And because we have all this great open source code available, and because you guys are not going to listen to me anyways, I have a challenge. I'm actually going to give you a programming challenge for the rest of this keynote. So whip out your laptops, those of you that want to listen anyways, and do this. So I want you to write a CoAP client. Write, I mean code, Java, don't JavaScript, whatever language you want, do C if you like. And talk to my server. So I'm actually writing a server on this machine. This is its URI, coap://192.168.80.121. So just remember 80.121. Standard CoAP server, I won't tell you any more than that. Your task, write a client, discover my resources. There's discovery built into CoAP. You'll figure out how to do that quickly. Get the question, put your answer, and include your name, because otherwise I don't know who wins. Include your name. If somebody manages to do this by the end of the keynote, 10:30 or 10-ish, I will give you a development board for this stuff, which is pretty cool. Very nice. So something to play with for the rest of JFocus. I'll come back to the IP address again soon if you don't remember. A hint, Californium's a really cool open source library from the Eclipse guys. Author of Californium is here. You are disqualified. You're not allowed to participate in this. He knows this too well. So is Schumann. You're disqualified too. Because he wrote this server in 10 minutes last night at the bar. I gave him a challenge. Hey, you want to write a server for me tomorrow? So he wrote this in 10 minutes over a drink. So this doesn't take too long. Copper is another hint. Firefox plugin. That's cheating. You can use it to play with it, but if you do it with Firefox Copper, you're not going to win the prize. So you need to code. So get started on that while we finish the talk. So let's talk about why we need this common technology across different market segments. So that's an espresso machine. It's almost as cool as the toaster. And if you look at smart home, there's stuff you need, right? You need security. You need to be able to provision devices, take care of their management. We need an OS, we need drivers, right? Basic stuff. We need connectivity. So in the home space, it's Thread, it's Bluetooth Low Energy, it's Wi-Fi, all IP-based these days. And then you write an application, right? That's your app. By the way, we don't believe in apps in this space, not for these small devices. The device is the app. That's how we think of it. You write your logic for your device, that's your app. You want to get a different app, get a different device. These things are going to be really cheap, right? So these are different than high-end wearables that you'll actually put apps into. They're more like mobile platforms running Android Wear. Smart cities, that's a street light if you can't tell. It looks kind of weird. That's a street light, a real one we've actually put technology into. You need the same stuff. You need security, you need provisioning. There's no application you don't need this stuff for, right? You need an OS, you need connectivity. It's actually very similar. These share exactly the same underlying technologies as this, same IP stacks, same communications, right? You need an app. Same thing for low-end wearables. You need, this is more based on Bluetooth Low Energy than anything else, but you need a lot of the same stuff, right? So we can actually provide a common software foundation, talking about software ecosystem, right? We can get software for all these things and make it reusable, right? If we just know what we want to do. And we can give all the connectivity standards we need. And that's the starting point for IoT, is getting the same software available for all these devices. That's the challenge we're working at. Now, we tried this out a few years ago. We have a prototyping system at ARM I'll tell you about in a moment. And we said, wow, how hard can it be? Let's go make an entire system and go look at what kind of complexities there are in making an end-to-end solution for IoT. This is pretty interesting add-on to an espresso machine. We like coffee. You guys like coffee. An espresso machine, right? Old coffee makers are out. There's new stuff. This actually detects the color code of the capsule as it goes into the machine. You have these different colored capsules, at least in Europe. And then it goes and lets other services take advantage of that. So for example, at a recent trade show, we built a bar, a real bar at the trade show with alcohol. And we had this espresso machine, and every time you put in a capsule, it detects that, goes talks to a service, which then controls all the BLE LED lighting on the entire bar. So the entire bar would turn the color of your coffee drink, which we thought was really cool. If it could do the same with beer, that would be nice. But it takes a lot of work to do this, right? This is not a simple thing to do today, right? You got to do the sensing algorithms, all your debugging toolkits. This used to be fairly hard to in your tool setups. You need connectivity. You need a server, right? You need a server that speaks this stuff too. It's not enough to just have the device. You need to deal with security, key management, on-device security. Hear more about that later today. Device management, right? You can't put these devices out there and not update them. That's why most of these things are insecure in the past, etc. Right? It's a lot to do. So we want to remove as much of this as possible. A lot of this is stuff that's common, so let's remove all that and make it something that people can use. And ARM realized this already about 5 years ago and started working on something that's called Embed. And Embed is what this little board is based on. Embed is a free software toolkit for programming all of these small devices, so sub-CPU, microcontrollers. And the idea was, how easy can we make it to develop these things, right? Can we just, what is it we have to do? Is it cloud IDEs? Is it open source code? Like, what's the magic formula? And it turns out the magic formula was, hey, we need free code, that's good, and you can put in devices, and we need free tools. So we built an online compiler. We actually host compilation with commercial tools, so ARM makes tool chains as well. We actually give those away in the cloud. So anybody can come and build their software in the cloud, and we just give them the binary. And this has really taken off. We actually just hit today, this week, 100,000 developers. So that's been a pretty good start for the embedded world. It's not the Java world. We don't have 9 million developers. There's maybe a few 100,000 in the whole world. So this is an area where we need people. And we build over 27,000 builds a day. So people actually use this pretty heavily in the cloud. It's pretty cool stuff. Lots of supported platforms. This is something we call Embed. And this is the start of what we were doing to go and build tools that the embedded industry needs. It wasn't enough. We had to go further. More recently, we announced that we're actually going to go and not just build some tools, but we're going to build an entire operating system for this space, something we call Embed OS. And basically what we're trying to do is create a free Apache licensed software ecosystem for small embedded devices. So give all the software you need for developers for free. Try to make the tools easily available, free tool chains, etc. This is what we call Embed OS. So free operating system for low power internet connected stuff. We're building an ecosystem around that, so we do it together with partners. ARM puts resources in, but we can't do everything. And then something else we're doing is helping cloud guys. So we actually work with cloud partners to help get them the cloud connectors in to speak with all these sometimes exotic web protocols, even though they're web, they have some differences, and security. And we try to make that easy, and we actually do it in Java. So a whole bunch of our developers are here today from ARM as well that do the cloud stuff. So I'll talk a little bit about this and then why this matters at the end. So we actually have a pretty good set of partners involved with this. So it's not just us. We have a lot of chip makers making actual boards. So this one's from NXP. We work with people that make gateways like Multitech, all the way up to the normal suspects in telecom and cloud, right? So these guys want to make sure there's a market for all these internet-connected devices. And one of our big missions is not only to give the software, but to give the standards. So I'll show you our standard stack. And you see that we actually have huge variety of standards we put in here. And what that does is that makes sure that anything powered by these is compatible with any service from these guys. That's our goal, right? Take a microcontroller, make your cool little device, And then you just choose what cloud platform you want to use. Do you want to deploy on Salesforce.com? Awesome. Deploy on Salesforce.com. We'll make sure with them that this actually works. Well, it's kind of like the mobile industry. You get a phone, it actually will work with an operator. Right? It's a SIM card or it's some setting, but it's pretty simple to get working. So we're trying to get to that same stage. And the way this works in practice is that, well, we work with silicon partners. They contribute drivers into the project. Together, we provide software and OS, free download for people. They include that in a device. First a prototype, and then it gets closer to the actual product. And they write an app. That's the app part. It's one app, usually. They get that to production. So usually they need help. So they buy modules, they might get it manufactured, they have system integration help. And finally, that goes to product, which goes to service. And we're trying to make that compatibility there between this and the service. This is something we call little data. So we're really trying to ensure that all these standards come together in a way that we provide end-to-end IP connectivity. We're trying to avoid gateway breakage. So we believe there's a role for gateways, but we don't believe gateways are kind of the answer for everything. It's something to keep in mind. There's a big trend in gateways right now, but really we want end-to-end security, end-to-end IP as much as possible, right? We want to know the source of our information and control that. The place where gateways become interesting is where you have a real added value, right? Let's say you have a building automation system. You want that to function even if the internet's down. That's added value, right? So you might have local intelligence that keeps all the automation systems running even when the cloud is down. This is where a gateway makes sense, right? But then you're using these standards in order to do that. You're not just doing gatewaying for the sake of lockdown, which is what gateways used to be. Right, so what are we doing in this OS? Well, we're sticking in a bunch of interesting stuff in communication, so basically all the communication standards that we see that people need. TLS, we have an exciting announcement coming out actually next week around TLS and DTLS. We think that's going to really change the whole industry. So finally we'll have some serious security available for these small devices. So keep an eye out for that. And on top of that, all the communications that we need. So we're putting in CoAP, HTTP, MQTT, whatever a small device needs to talk to the cloud guys, we're including it in. And something that's really interesting, I think this ties into the afternoon's presentation, is that we believe in addition to communication security, we really need device security on these devices. And traditionally, microcontrollers don't have any kind of segmentation within them. It's basically one memory in flash space. So if I'm storing a key over here, this piece of code over here can access that, no problem. Right? This is traditional microcontroller development. We're bringing something we call CryptoBox. This is basically the equivalent of Trust Zone, so trusted execution in mobile platforms, where you actually cryptographically segment out part of the memory and code space. So you can do things like key storage and crypto calculations securely. So that's the first time this has ever come to microcontrollers. We're pretty excited about this. And we think that'll change the way people actually secure their devices. So very cool stuff. So can you get a microcontroller secure? I'm going to answer. I'm going to challenge the guy in the afternoon. I'm going to say, yes, you can. But up till now, it's been kind of bad. The tools haven't been there. Admit that. We're just alpha testing this with partners right now. So this new version of Embed, the old one is there. It's pretty cool, but it's not awesome. This new one is going public in August timeframe. So just not to go look for this right away. And that will be Apache then. So we're actually doing open source. Okay, let's talk about Java. Let's go back to Java. So most of the time, we do native C++ applications because this is pretty efficient, low-level stuff. It has to do with drivers, has to do with timing, and we just have a lot of people that are good at that when it comes to the low platform support. But when it comes to upper layer intelligence, actually things like Java ME in particular, JavaScript, Python, all make a lot of sense, right? You can do some basic scripting functionality. Somebody can change the functionality. An app developer can change it, not a platform developer. So we see the split coming between platform guys and the guys writing the actual device functionality. So what does this display show me when I press this button, right? That could be done in Java ME. And we've actually done this. It's pretty cool. So we've teamed up with Oracle, some of our device platforms. Unfortunately, this one's not a Java ME platform. I couldn't get one in time. This is a C++ one. To go and bring the new Java ME 8 to these platforms. And the old Java ME, to be honest, it sucked, right? It was Java 1.4, right? And it had so many different profile variations that nobody could actually use their code back and forth. It sucked. Java ME 8, the guys at Oracle have actually done a really great job. So ME 8 actually is a subset of SE 8. You can move code back and forth pretty easily. Container structure is different. But otherwise, there's a lot you can do that's in common. So that's going to be much more exciting. And this is now available. So we've actually released a developer preview of Java ME Embedded 8.1. You can get this from OTN. And this runs on an Embed platform from Freescale. This is about, just to get an idea of the size, right? This is about 256K of RAM, a meg of flash. Just $25, right? It's not expensive. So it's not huge. It's nowhere near the size of a Raspberry Pi. It's much smaller, but we can run Java ME on it. So I recommend checking that out, playing with it. It's a good way to get started with IoT development before getting into C++. Now, I don't believe this will be the only solution. I think Java ME has its place. I also believe JavaScript has its place in this area. I think we'll see some pretty nice JavaScript functionality on these devices and the ability to update functionality easily. And if we think about getting kids involved with programming on embedded devices, that's pretty nice. Just doing some basic JavaScript is probably the level that we want to get kids into programming on embedded. We do some cloud technology. I'm not going to talk a lot about this, but we actually have a free version of this available on the web. So if web developers want to get involved with how do we talk to these devices, I just don't want a device, but I actually want to go build a Java-based UI framework around it. I want to graph something. I want to control it. We have a free development version of this people can go play with. And it's pretty easy. You end up with a REST API on top, and you can go and control devices. You can get feeds of notifications coming from them, etc. So pretty much what you're familiar with REST APIs in the web world. Now, let's talk about Toast again, and espresso machines. I'm an espresso lover. Notice the Google guys have an espresso machine downstairs. Should be fired up about now. That's going to be nice. Swedish coffee is just as bad as Finnish coffee, so we're equal that way. Let's talk about Toast. So this gets a lot more complicated. This is where the cloud side comes in. So these systems end up looking a lot like enterprise logic, right, in the end, when you go build them, right? You've got a toaster. It needs something from the weather forecast. You've got a coffee maker. You might want to control these things. Set them up. When do I want toast and when do I want coffee? You may want some analytics. The coffee maker could be hooked into Amazon.com's ordering system, right? That would be really cool. When I run out of coffee because I know I'm down on capsules, they automatically ship me some. I don't have to remember to ship. My wife doesn't nag me that, oh, why don't we have any coffee? It just shows up at the door. That would be nice. Maybe I have my smart watch, or not so smart watch, in the mix, right? That might set the time. It knows when I went to sleep, so it tells when I want my coffee in the morning, right? There's a lot of things you can do to tie stuff together. But this actually requires a whole bunch of web work as well. It's not just embedded. So we need some little data, and we need some big data. We need a browser interface, so we need to use some tools to actually get this browser working. We might host that on Amazon. We might do some big data, right? On the Amazon side and Nespresso side, we may actually track these capsules. We may look at different trends. Do people drink coffee on a cloudy day? Do they drink coffee on a sunny day? You know, there's interesting information to get about consumers from this. And we might store that in a different place. We do real-time stuff with apps. We end up hooking into the little data, so hooking into these devices themselves. On the web edge, that could be in the local server, or it could be all the way on the cloud. And then we have to do this in scale, right? This is how it used to be. We used to build these things one time, but now we're actually looking at building them in scale. How do we do this? Billions of devices, tens of local servers, dealing with lots of mobile and browser interfaces. This ends up being a cloud-scale web application in the end. And I tell you, from building a lot of these, they look basically the same. And that should be a comfortable thing for everybody at JFocus, is that actually IoT, when it comes to the application side, won't look all that different than enterprise or anything else we do on the web, which is good. That means we can reuse all these great tools that we have. We don't have to reinvent the wheel. So, kind of wrapping up, what was the future of IoT? I didn't really talk about this. I talked about the history, what it is, what's happening. But what is the actual future? I think this is pretty easy. Like, a lot of people expect that some smart guy from some big company with a nice title is going to come up with these cool future stuff, is going to have the answer for all the technology. I don't think that's the case at all. I think this is like total grassroots type of field. So I think the answer is totally, it's this, it's you. So I'm not going to create the cool applications, right? I'm too drowned in the technology platform we're building. I need somebody who's going to go solve that problem. That's the next big problem. Reinvent the thermostat, right? Change the way you give taxi rides, like what Uber's done, which is business model innovation. It has nothing to do with technology innovation. It's business model, right? So I need you guys to go invent the new, coolest thing, the coolest application that's going to be out there. Yanzi is a great example in Sweden, home automation startup. They're here at the show. Make really cool, reinvented home automation. They make it easy, they make it internet-based, right? That's an example of innovation. And to learn more, recommend people to go take a look at embed.com. We have a whole bunch of free developer stuff there. CoAP.technology's got a lot on standards. The Thread group has tutorials on what they're doing. And you can always find me on Twitter. Feel free to just like chat what you have in mind. I might point you to some good information. And now with a little bit of time we had left, we wanted to do a Q&A. Hey, let's check quickly if we actually have any winners in our little competition. Ooh, not yet. You guys have a little bit of time left. Right. So some Q&A. If we have any questions, anything at all in this whole space, myself or our other speakers, we could answer you. You don't have to wait for the mic. Just shout out and I'll repeat your question.
So what are some of your security concerns as this proliferates?
What are some of the security concerns as this proliferates? For the most part, it looks a lot like the PC and mobile industry. So it's not that different in that respect. So you're going to have problems with DDoS attacks on the infrastructure itself. We have problems with device security, so just getting information off the device. But then you have other things that are a little bit different, right? So you might have denial of service attacks aimed at the actual device. So if this device is controlling something that's critical, that can be a real issue, which we don't typically have with mobiles, right? We don't get that kind of problem. We have problems with people hacking into devices to actually steal crypto information to go hack the system itself. And that's where we get into issues with on-device security, secure key storage, and just proper use of public key infrastructure. Because this is an issue in old systems. It used to be pre-shared keys, right? You hack that one pre-shared key off the system, you now have the key to act like any device in the entire system, right? Which was crazy. So we're very much rooting for the use of asymmetric technology and all of these things. So it avoids that problem. Communication security in general, so people just trying to modify information as it comes through. We're going to see that problem. If you can modify enough electricity information in an electricity system, for example, you could in theory cause a blackout. So if you're basically faking what's happening in an electrical network, you might cause it to react in the wrong way. So things like that, if you do them at massive enough scale, it could have consequences. I think the end answer is that infrastructure has to be protected just as well as we need for other cloud applications. Devices need on-device security like TrustZone for mobile, and we absolutely need public key-based real communication security. I think those are the kind of three main areas. And then we need people designing these systems that care about security. That's the other issue, is that a lot of the engineers that are developing systems for embedded, they came from a space where security was unplugging the cable. Right? They left the developer account in there because they thought that nobody else was going to plug the cable in except for our maintenance dude, right? So I think also we need some security experience from other industries where we really have to think about it, because the embedded guys never had to. A few things. Any other questions?
Yeah. What about retrofitting existing technology for IoT?
What about retrofitting existing technology for IoT? So I think there's a few options there. One of them is going back and doing software updates with new protocols. So a lot of the technology I actually talked about is pretty efficient. We can do it in really small amounts of flash and RAM. As long as there's some internet connectivity of some kind, upgrades are doable. Now, if you have old technology, as in like Z-Wave communication, where this thing's really not compatible with the internet, then you do gatewaying. And we see a new trend in gatewaying where we're actually doing web wrapping. Gateways used to be like, oh, I have this proprietary protocol, so let's make a proprietary SOAP interface to that proprietary protocol. Then we're really good, right? That was the solution for years and years, and that sucked because now you have another proprietary thing to go interface with. So the change is that now people are saying that, hey, let's wrap the proprietary protocol with the same web objects, the same web standards that we would use with the real one, right? And in the end, you can't tell the difference. I think that's the right way to go, right? Basically, make those old legacy stuff look like it would be a modern designed web interface. Other questions? There.
What about the privacy concerns if you have a lot of devices in people's homes and on people's bodies, etc., and connect all of them to the cloud?
So I think technology-wise, we're doing some of the things we should be doing. So we have a lot happening in the IP world with IP address randomization. Bluetooth Low Energy does a lot with identifier randomization. But I don't think privacy is a technology problem. I think the privacy issues we're going to see in IoT are the same privacy issues we're seeing in any user-based system, which is what's acceptable to us as consumers that companies, for example, do with our data. It's going to be the exact same problem. I'm not so worried about the physical tracking, right? We have that with mobiles today, right? We can be tracked endlessly. That's not usually the problem. The problem is what happens when we send our data to Google. How much do we trust them? Do we trust Facebook? I'm not even on Facebook for some of those reasons. Do I trust Facebook with my data? Do I trust that it's worth it? I get it for free and they do that? IoT will be no different, right? I hook my thermostat up to a service. How much do I trust that service to be able to do with my data, right? Do I opt into something? Do I opt out? So I think it's going to be more of those user terms of service kind of issues. They're going to get more complicated, right? Because of this.
Following up this last question. So when the web came up, those issues with privacy, they were not there yet. We didn't know where we were going to go. So now this is 2005. Are there technologies that are designed with these privacy issues in mind in this world of IoT?
So some, but they're purely technological. I think you haven't seen yet the ones that are protecting the user yet. So for example, technologically we can randomize identifiers in physical devices, right? So you can't do just basic network tracking and IP address tracking. You're not going to know who that is. However, that doesn't mean that when you log into a website, they're not going to show you advertisements aimed at you. Right, so a lot of the privacy protection mechanisms today are, for example, search engine front ends to Google that protect you from actually giving any personal information to Google or showing you any kind of advertisement, right? Ad blockers. I don't think that'll be so different for IoT services, right? I'm going to want to protect my privacy as an IoT user. Now, do I actually sign up my thermostat, which is randomized, as a random thermostat, like a fake account on a service, and then I have a fake front end that gets the data without saying who I am? Maybe, right? That's kind of interesting. People do that with Facebook, right? Fake account, follows some things, but nobody really knows who you are or what you're doing. So I think the problem is similar, but some of the ways that the data is used might be new, and we don't know what those are yet. That's part of the issue. For example, the insurance industry is an interesting one. There's a lot of concern, even with economists right now, how will insurance data from sensors be used for people's insurance? You know, if I'm doing something completely unrelated, not even knowing that the insurance company is getting this data, could it totally affect what I'm being charged? It's not such a problem in Europe, it's more a problem in the US, but it's coming. And that's like a whole completely unknown area, how it should be regulated.
Thread, it won't be open source, right? Or?
It will be. We're open sourcing it.
Okay.
Yeah. So, yeah, these alliances, when you have new like Wi-Fi-like alliances, typically it's ones that companies have to join and they get the spec. And then the old school way of doing it was, ooh, I did a Zigbee stack, binary, right? And I'll charge people for it. But at ARM, no, because we're building an open software ecosystem, we said, now we're going to implement that and give it away. So it'll be open source. Yeah. Other questions over there?
Yeah, I have a question about what do you think is the role of Java in these embedded devices? Because now we have sort of these real-time operating systems, we have frameworks and so on, and building the application for the constrained devices is becoming really easy in C or C++. Why do we need Java with non-real-time, with the computation overhead and everything on these constrained devices?
That's a good question. So why do we need Java on constrained devices? There's some solutions today. Like the one I just told you about, Embed OS is all native C++. It'll be easy. You can just write your app in that. Why do you need Java? And the answer is, a lot of the time you won't need Java, to be honest. You'll do native development, and if you have that skill, that's fine. But there will be a class of devices. We're seeing this kind of high-end microcontroller, and these microcontrollers are getting powerful fast. Like the newest Cortex M7, so that's a microcontroller, right? It's not a CPU. It's actually more powerful than the old Cortex A5s, which is a mobile Linux platform, right? It doesn't have the flash and RAM, right? So, and we're not going to be able to run a full operating system, but it's got the computational power. And what we're seeing happen is that actually there's classes of applications where you want to, for example, separate out application logic completely from the platform itself. The platform can be sometimes really touchy. You've got mesh protocols and security you're dealing with. It can be some really even regulatory stuff happening there. But then you might want this really cool app developer that's going to make this nice logic and UIs. You want this logical separation between the two. And we've actually had real companies, really big automation companies come and ask for this. Actually ask, hey, we want to do Java ME on top of a smaller operating system. So I think we'll see Java, but I don't think Java is the only answer. I think we'll see JavaScript for that purpose too. So it's a mix.
You talked about sort of one application per device, but don't you think that there will be sort of more devices than sort of tablets that you have some kind of app store or whatever?
It's a good question. I don't think it'll work quite like that. I think you'll have multiple functionalities built into a device. But these devices, I mean, the interdependencies between applications, they're much, much greater than in a full CPU. So you'll have functionality, and I think it'll be updated over time. But I think what we're going to find is instead of installing a new app every time you want to use a service, right? That's how it works on our phones right now. I think we're going to have compatible web-based interfaces, small services on the device that multiple services, cloud services use, right? So I could see like a service store, right? Like I have my my home thermostat, right? And now I said that, yeah, okay, Nest, I'll sign up for your service. But then next month, a new cloud service comes, mycoolthermostat.com, right? And these guys are hooking in some new weather data, and there's a party meter, and I don't know, there's all kinds of cool stuff. And I want to opt my thermostat into that service. I think that kind of thing we're absolutely going to see. That I say, hey, I want to sign my thermostat up to that service. I didn't have to put an app on the thermostat to talk to the service. I just I bootstrapped the device with TLS onto the service. I got the right certificate in, and now I've exposed my REST interfaces to them, and it's based on standards.
But if you talk about a bit bigger and
So when you talk about a little bit more powerful devices, so not quite like Android Wear. So if you get into Android Wear class devices, apps, absolutely. Although I don't know, will apps die? I've been hearing lately that apps are going to kind of die after a while. But this watch is a good example. So this Suunto watch, I can actually install like basically script logic. I actually don't know exactly what the language is. Haven't been able to identify it yet, but it's script logic. So for kind of higher end ones, I could see like little scripts getting installed, downloaded by users. But maybe not full apps. I think it's more of a functionality problem, right? Like, what do I show on the app, right? It's very limited UIs, very limited interfaces to people. Other question? How are we on time? We have a little bit more time. Yeah?
I have a question. One's talking about home automation, so when you have a light and heating and everything,
Mm-hmm.
and how there are so many proprietary solutions and the lifespan of a house is like 50 years easily. So how to sort of maintain that kind of, okay, maybe if my sort of sensor realize how I'm going to do the replacement of 10 years, because there are any like, approaches to that long-term support.
That's a good question. I don't think we figured out how to solve the problem yet. I mean, we know the current one's broken, right? Like, most of the modern home automation systems are silos, complete silos. So they're from one company and you have to buy everything from one company. I think what will change is we'll be breaking down some silos. So as some of the silos break down, you're going to see more companies having products that are compatible with each other. And I think you're going to see more openness, right? Like, you can enroll your devices in different cloud services. And then I think as services evolve, you'll be able to enroll new devices, you'll be able to put old devices. I think it'll just be a more open ecosystem. And that will help. It won't solve the problem completely. But it's the same with any technology, right? Like, look at your old stereo equipment. Some of that starts to be so old it's not really useful anymore. I think we'll see that in homes as well. Any other questions? Okay, one more.
Should we move devices like 3G and 4G? Would it be standardized communication protocols to allow for only device-to-device communication, simpler than with voice and then?
Yeah, so the question was about 3G and 4G for mobile devices, like thing devices. Will we have specialized protocols for, well, I guess, network or for device-to-device? The answer is yes. So we're seeing the trend right now in standards. I didn't really get into what's happening with cellular. We are definitely supporting cellular because in a lot of smart city applications it's pretty key. And what we see happening is that cellular is coming down, and then there's a new class of low-power RF networks that are coming up. And we don't know yet how they're going to collide or which one's going to win. But basically there's something called Cat0 LTE. It's the very low end of LTE that's being developed right now, which is supposed to provide more machine functionality. There's also some new M2M specs from GSMA or from 3GPP that give some better signaling performance, et cetera, for devices. But in the end, it's still the same cellular model. So Cat0, I think, is going to be like 1.4 megabit per second or 1.5 megabit per second. It's fairly fast for a simple thing. At the same time, there's new kind of proprietary things coming up like Sigfox and LoRa, where there's technologies where people can run their own RF networks. And those are very low end. It's like 10 bytes per minute kind of thing. And some of them are a bit faster, like 20 to 50 kilobit per second. And those are making a big impact right now because they're cheap, right? Put one base station up, it covers 50 square kilometers, and it's cheap. Those are being deployed, especially in Europe right now, and we're yet to see if those will become part of the cellular network someday. I think eventually they'll be bought into the cellular network, and it'll be like Cat -5 or something, part of the GSM standards. Cool, one last question. I'm waiting for somebody to solve the programming exercise. I see some guys with laptops open, so. All right, great. Thank you, everyone. Awesome questions. I'm sorry we didn't have dancers. If I would have known, we would have found dancers.
Yeah. So you will be around for the rest of the conference?
Yeah, I'm around for the rest of the conference.
So catch him if you can.
Yeah.
And the next presentation starts at 11, so there's coffee served in the exhibition hall. And the IoT sessions are down at level 2 then, all the stairs down to level 2.